Hi children, today we are going to study about nature and properties of matters. The structure given here is showing you what are the topics we are going to discuss under this lesson. Matters, pure substance, mixture, elements, compounds, homogeneous mixtures, heterogeneous mixtures. Firstly, we will see what are pure substances. Matters that contains only one constituent with specific properties are called pure substances. Examples: copper, carbon, copper sulfate, aluminium, sodium chloride. A pure substance can be an element or a compound. What are elements? They are pure substances with specific properties which cannot be further divided by either physical or chemical methods into substances with different properties. Example: copper, carbon, chlorine. These we can't divide further by physical or chemical method. There are about 120 elements have been covered at the moment. Let's see what are compounds. They are also pure substances. They form with specific properties which formed by the chemical combination of two or more elements in a fixed rate. That means there can be more than one element. Example: sodium chloride, copper sulfate, glucose. In these compounds, you get more than one element. Let's see how we are naming these elements, or how we are giving a symbol for these elements. There are internationally accepted symbols to indicate elements. When we are writing a name of an element, always first letter should be a capital letter. When you are writing the symbol, also the same. First letter should be a capital letter. Always we are taking the first letter of the element as the symbol of the particular element. For example, carbon starting from letter C. So, as symbol of carbon, we are taking capital C. Hydrogen starting from letter H. So, the symbol of hydrogen we are taking as capital H. Sometimes you are getting elements starting from the same letter. At that time, how we are using the symbols for these elements? For example, this table. Chlorine and calcium both are starting from letter C. So, we can't indicate both elements with the same letter, capital C. At that time, we are using another letter to help that symbol. The second letter should be a simple letter. Therefore, chlorine we indicate as Cl, capital C and simple L. Calcium we indicate capital C and simple A. Another example, aluminium and argon. Both are starting with A. But when we are writing the symbol aluminium, we are writing with capital A and simple L. Argon, we are writing with capital A and simple R. Most of these elements are in English. They are having English names. So, we are using the first letter of the English name. So, I told you there are more than 120 elements we have found. So, at that time, when we are giving the names and symbols for these things, it is little bit difficult. Therefore, sometimes we are using Latin name to give the symbol. Now see this table. Sodium, copper, lead, gold, mercury, iron, silver. All these elements giving the symbols with their Latin name. Sodium, Latin name is natrium. So the symbol is Na. Copper, the Latin name is cuprum. So the symbol is Cu. Lead, plumbum, symbol is Pb. Gold, aurum, symbol is Au. Mercury, hydrogen, symbol is Hg. Iron, ferrum, symbol is Fe. Silver, argentum, symbol is Ag. In these two tables, we are giving few symbols for some elements. Building units of elements. Now we learn all matters are composed by particles. And these particles we can't see from our naked eye. So small particles in these matters we known as atoms. The word atoms used for the first time by the scientist John Dalton. And the word atom, it's deriving from the Greek word atomos. The meaning of atomos is cannot be divided further. So all the matters are composed by these atoms. What we can say about atoms? An element is composed of the atom of same type. For example, we take element aluminium. This is made up of aluminium atoms. You can get there only aluminium atoms. The atoms which form different elements are different to each other. Example, iron is formed from iron atoms. Copper is formed from copper atoms. So the structure of the iron atoms and copper atoms different from each other. Molecules. The units formed by the combination of one or more atoms of the same type or one or more atoms of different types are called molecules. So, in a molecule, there should be more than two atoms. So these two atoms can be same kind or different kinds. We will consider some molecules. Molecules having same kind of atoms. Examples: hydrogen molecule. Two hydrogen atoms together form hydrogen molecule. Oxygen molecule. Two oxygen atoms form oxygen molecule. To make chlorine molecule, two chlorine atoms are joining. Molecules having different kinds of atoms. We'll say very common molecule, water molecule. To form a water molecule, two hydrogens and one oxygen should join together. Hydrogen chloride molecule. Hydrogen atom and chlorine atom together form hydrogen chloride molecule. Now we'll learn about the small particle atom. Observe this diagram thoroughly. In this diagram you can see greater part of the atom is empty. And there is a small core at the center. So the entire mass of this atom is concentrated on this small core that is known as nucleus. And what you can see in this empty area? We will see. There are three subatomic particles in an atom. They are electrons, protons, and neutrons. I told you the mass of this atom is concentrated on the core. So the protons and neutrons you can find inside this nucleus. And electrons, we can see around this nucleus. They are rotating in this empty space, just like the planets are moving around the sun. Same like the electrons are situating around this nucleus. We will see about these subatomic particles more. Protons locating in the nucleus. Relative mass is 1. They are positively charged. Neutrons, they are also in the nucleus and the mass is 1. They are not having any charge. Electrons, they are around the nucleus. If you are talking about the mass of the electrons, it is very, very less compared to protons and neutrons. They are very light, but they are negatively charged. Protons are positively charged. Neutrons, they don't have any charge. Electrons are negatively charged. Ernest Rutherford. He is an English physicist and chemist. He is the one who found that The atom consists of a large empty space and positively charged central nucleus. Now let's see atomic number, which indicate with capital Z. What is atomic number? The number of protons present in the nucleus of a given atom of an element is the atomic number. An element is the atomic number. I told you atoms are consisting of protons, electrons and neutrons. So, the number of protons present in the nucleus we are taking as the atomic number. Number of proton is a unique property for the element. That means it is changing to element to element. But it is same in the same kind atoms in same element. Just like this. If we are taking element copper, all the copper atoms have the same atomic number. But if we are taking copper and aluminium, the atomic number of copper is different from the atomic number of aluminium. And when consider an atom, the number of protons always equal to number of electrons. You know, protons are positively charged and the electrons negatively charged. When both protons and electrons are in same number, so what will happen to the atom? It will be electrically neutral. Why? Here protons are positively charged, electrons are negatively charged, and both positive and negative are equal. At that time, an atom is electrically neutral. Mass number indicating with capital A. What is mass number? The sum of the numbers of protons and neutrons in the nucleus are known as the mass number. I told you the mass of the electrons are very high. They are very small. They are very light. Their mass is relative to neutrons and protons very less. Therefore, the mass of the atom is almost number of protons and number of neutrons. So, the sum of these two consider as the mass number. Mass of the protons and mass of the neutrons. We take as the mass number. To write these things, to indicate these things, there is a internationally accepted way. That is given here. Element X, how we can indicate the atomic number and the mass number. Here A is indicating mass number, Z is indicating atomic number. So, example, we will take sodium element. So, in a sodium atom, the mass number is 23, atomic number is 11. So, in an atom, only protons, electrons and neutrons are there. So number of protons, how can you take now? It is atomic number, that is 11. Number of electrons, that is also 11. Why? We know number of electrons equal to number of protons. Number of neutrons. You find the number of neutrons. Mass number is the sum of protons and neutrons. And already you know number of proton is 11. So mass number is 23. Then you will get the number of neutrons when you subtract 11 from 23. That is compounds. Compounds are formed by the chemical combination of two or more elements in a certain ratio. Some of those compounds exist in nature as molecules. Compounds with the same kind of atoms we call homoatomic molecules. Molecules with different kind of atoms we call heteroatomic molecules. For example, we'll take hydrogen chloride. Hydrogen atom and chlorine atom together form hydrogen chloride molecule or compound. If you are taking water, you can see in this figure, one oxygen with two hydrogen atoms are formed water molecule. Carbon dioxide molecule. One carbon atom and two oxygen atoms together form carbon dioxide. Next, ammonia. One nitrogen with three hydrogen atoms form ammonia molecule. Finally, methane. One carbon atom with four hydrogen atoms together form methane compound molecule. So, these compounds we can write as chemical formulas. These compounds can indicate with chemical formulas. What is a chemical formula? Let's see. Why are we writing chemical formulas? You know, water molecule. When you say water molecule, can we identify the elements in that water? No. So in science, we are using a chemical formula with the elements in the water molecule. So, water molecule is composed by two hydrogen atoms and one oxygen atom. So, we are giving the formula as H2O. And when you see the chemical formula, you can identify what are the elements are there. So, water molecule, H2O, there are hydrogen and oxygen atoms. Always we learn an element starting with a capital letter. Some elements are there, one simple letter as a support. So we'll see glucose compound, C6H12O6. Now at when you see at this formula, you can see carbon, hydrogen, oxygen together form the glucose molecule. So in this table, few examples are there. You from looking at these formulas, you can identify what are the elements contained there. Okay, we know different elements have different properties, but the elements with different properties are together form compound. Now what is their properties? How we can understand this matter? The elements contained in the smallest unit that goes from a compound cannot show the properties of that compound. Like even water molecule formed by hydrogen and oxygen, the water molecule doesn't show the properties of hydrogen or properties of oxygen. It shows the properties of water. The different compounds formed by even same set of elements have different chemical properties. It's like this. Sometimes some compounds are there, they made up of same elements, but in different ratios. Even they form with same elements, but they are showing different properties. We will see one example. Compounds with carbon and hydrogen. You can see in this table there are about 5. There are 5 compounds: methane, hexane, benzene, acetylene and ethene. So all these compounds are made up of carbon and hydrogen, but in different ratios. These compounds are showing different properties. Even they made up of same set of element, they are showing different properties. Let's see another one. Compounds with carbon, hydrogen and oxygen. Here also glucose, acetic acid, ethanol, dimethyl ether and sucrose. You can see here carbon, hydrogen and oxygen atoms, elements, but they join in different ratios. So these compounds are showing different properties to each other. Mixtures. A matter which consists of two or more constituents which can be separated by physical methods are called mixtures. The constituent in a mixture can be separated by physical method. Elements couldn't do that. They can't separate it by physical or chemical method. But the constituent in a mixture can be separated by physical methods. They are non-pure substances. In a mixture, there should be two or more constituent, two or more pure substances. Let's consider about few mixtures now. Air is a very good example for a mixture. What are the constituents there? Nitrogen, oxygen, carbon dioxide, argon, water vapor. Air is a mixture of all these gases. So all these gases can separated by physical methods. Mixture. Seawater. Constituents: water, salt, dissolved oxygen, dissolved carbon dioxide. You know, there are water in sea and also salt are dissolved in it, and not only them, oxygen and carbon dioxide also dissolve in them. So seawater is a mixture, and the constituents in that mixture can separate by physical method. Cake mixture. When you're making a cake at home, what are the ingredients you use? Sugar, flour, water, coloring, butter, eggs. These are the constituents in a cake mixture. Crude oil, which we use to separate all the types of fuel. Diesel, petrol, kerosene, tar. So the crude oil is a mixture of these ingredients. So these constituents can separate by physical methods. Remember, always constituents in a mixture can be separated by a physical method. Mixtures are two kinds: homogeneous mixtures, heterogeneous mixtures. What are homogeneous mixtures? The mixtures with a uniform composition right throughout the mixtures. That means the constituents are equally distributed throughout the mixture. Let's take an example. We'll take an orange juice. To make an orange juice, what are the constituents you use? What are the constituents are there in orange juice? Orange, sugar and water. So you are mixing them nicely to make juice. When you are drinking it from bottom to top, top to bottom, the taste should be equal. When you are tasting, if you are mixing it thoroughly, so you can feel the same taste from top to bottom. Why is that? Because orange, water and sugar equally distributed in the mixture. Each and every place you will get the same composition. Think you are putting everything but you are not mixing well. Maybe you will get undissolved sugar at the bottom. So you can take it as a equally mixed mixture. To get the homogeneous mixture, you have to nicely mix it. Then you are getting the composition throughout the mixture same. Therefore, taste from top to bottom will be same. See this diagram. You can see how constituents are distributed. Constituents are shown in two different color dots. So you can see how they are equally distributed throughout the mixture. So this is homogeneous mixture. Heterogeneous mixture. That means the constituent in the mixture not equally distributed through mixtures in which the composition is not uniform throughout the mixture. Let's take one example. Muddy water. You know, when you mix muddy water, till you are mixing, it will give you a same color throughout the mixture. But as soon as you stop it, you can see gradually it's changing. So even from the color you will get it. The most of the mud particles deposit at the bottom, and top layer the water will be clear gradually. So muddy water, you can see mud particles are not equally distributed throughout the water. Another example we'll take fruit salad. We can't say each and every spoon, full of spoon, not equally distributed. The number of pieces of fruits will be different. You won't get the equally distributed spoons. So therefore, we call such mixtures are heterogeneous mixtures. That means the constituent in that mixture not equally distributed throughout the mixture. Not uniformly, composition is not uniform throughout the mixture. So you can see the diagram. The different color dots, see, they are not equally distributed. In one place, the concentration of the same kind will be more. Concentration is high in the same kind. So we can't say it is equally distributed. These kind of mixtures we call heterogeneous. At the beginning of the mixtures, we told the constituent in a mixture can separate by physical methods. What are these physical methods? Here are some: panning, winnowing, floating on water, sifting, vaporization, fractional distillation, steam distillation, crystallization, using magnets. So panning, you can separate sand from rice. So day-to-day life we use those stuff. Winnowing, same like that, separating chaff from rice. Floating on water, so you can separate sterile seeds from paddy seeds. If you want to separate gravel from sand, what is the physical method we use? Sifting. Vaporization, you can take, if you want to take salt from seawater, so the physical method we use is vaporization. Fractional distillation, you can separate various fuels from crude oil. Steam distillation, to extract cinnamon oil from cinnamon leaves, we are using steam distillation. Crystallization, making crystals. Sugar syrup is crystallizing to take sugar. If you want to separate some kind of mineral sand or something metallic something, so you have to use a magnets to separate. Those are from a mixture. Separating some minerals from mineral sand, we can use the method using magnets. So mixtures can separate by physical method. So these are the physical methods we use. Hope you got a better idea about properties, and hope you got a good idea about nature and properties of matters. Thank you. Let's meet with next session.